Dear students, good morning to each one of you. Hope so you all are fine and taking good care of yourself. Dear students, welcome to digital classes. समय 10 से 12 वाला हर घर बने पाठशाला. Chemistry class +1. We are doing structure of atom. So today we will start the topic discovery of subatomic particle and some basic structure of atom. We will discuss. But before, as usual, before going to start, let's start with the positive mindset. Dear students, don't stop when you are tired. Stop when you are done. Yes, you adopted science, and generally it's people thinking that science students are hard worker and silent, are very sincere students. So you all are now in this stream. Once, if and when you will tie your aim with your life, then that aim of life is your priority, and all things become possible. We don't feel tired anyone in that situation. So we are so consumed, we are so busy that we can't stop until we reach our goal. When the goal is our priority, we find time, we find energy, we get energy. So stay aback and don't stop when you are tired. Stop when you are done. Okay, so let's start. Recap about history of atom. Yesterday we have done history of atom. In the timeline you can see Democritus 460 BC and Dalton 1803. Two of the greatest scientists, those who played very important role in the chemistry field. Then after that, Thomson, Rutherford, Bohr, they started. So let me start. The idea that matter is made up of discrete unit is very old and was linked with the ancient cultures such as Greece and India. So Greek philosopher Lysippus and his people mean his student Democritus coined the word atom. So Democritus in 460 BC has coined the first time word atom, and however they couldn't put forward any theory in support of this. But in view of this, the first evidence-based theory was given by John Dalton in 1808. According to this theory, the smallest and the ultimate particle of matter is known as atom. An atom of same element are alike in all respect, while the atom of different element are not the same. So no serious attempt were made by either Dalton or his contemporaries. But in 19th century, then in the beginning of 20th century, some of the scientists like J.J. Thomson in 1897, Rutherford in 1912 and Bohr's 1913, they has played very important role. They with the help of their research established the atom is not a simple as suggested by Dalton. It is so much things are there inside the atom. They told about some basic particles of atoms, that is electron, proton and neutron. And in order to know about the position of these particles, where these electron, proton, neutron are lying in the atom, and this is called a fundamental particle of atom, this idea of nucleus and extra nuclear portion was given. These were all just in the beginning. The present picture of the atom is altogether different, and the credit for this must be given to those who have worked so hard to know about the structure of atom. So in this particular unit, we shall study about the earlier attempt in this field and also discuss the various aspects of the present picture of the atom. So dear student, in junior classes you have studied about atom. Atom have electron, proton, neutron, electron revolving around the nucleus, proton and neutron are in the nucleus. So this is just a basic idea of atom. But in this particular class, in this particular chapter, same topics we will study in the discrete way. You mean in present chemistry, in the present study, how the atom is there, what changes were there from the atom. Okay, so keep your eyes open, keep your mind open, and keep studying the previous topic also by keeping. So basically in this chapter, in this topic, we will discuss first about the discoveries of atom. We will discuss the three main part. First is electrical nature of matter. Second is wave nature of matter, and third is particle nature of matter. So first, electrical nature of matter. In electrical nature of matter, the electric nature of matter was indicated quite early in the form of frictional electricity, that is given by Michael Faraday in 1830. He showed the first chemical change occur when electricity is passed through the electrolytes. For example, 96,500 coulomb of electricity is passed through molten sodium chloride, and 1 mole of sodium is deposited in the cathode, 1/2 mole of chlorine. Okay, thus the Faraday for the first time established relationship between electricity and matter. So it is the contribution of Faraday also, and he also stated that electricity is made up of particle called atom. I mean, Michael Faraday was the first scientist who told electricity, inside the electricity there is atom. Okay, then later on G.J. Stoney in 1874, he suggested the name electron for that word. Now we are saying electricity, inside the electricity there are electron. This is G.J. Stoney has suggested. But before that, Michael Faraday has told the electron word atom. Okay, so the real credit for the discovery of electron goes to J.J. Thomson. So let's start the discovery of proton, electron and neutron. As in the previous topic we did structure of atom. Atom is the smallest constituent particle which has electron, proton and neutron, in which the discovery of proton was discovered by basically James Chadwick, and in his famous gold then electron, J.J. Thomson, and neutron, so E. Goldstein has discovered proton, J.J. Thomson discovered electron, and James Chadwick discovered neutron. So we will start in detail now discovery of an electron. You are very curious student, I know. You are very curious to know those electron, proton, neutron we studied in 9th class. Basically who discovered those electron, proton, neutron, and how they discovered electron, proton and neutron. Okay, so in this slide, in this video, keep watching this video carefully. Your all the doubts I'm trying to solve with the help of this video. So this is very interesting topic, discovery of an electron. An electron was discovered by cathode ray discharge tube experiment, in which a cathode ray tube is made up of glass containing two thin pieces of metal called electrode. You can see a very small picture is there given in the bottom, or you can see in the PDF file also, which I am shading. The electrical discharge through the gas could be observed only at very low pressure and at very high voltage. I'm going to, whatever is written here, I'm going to explain it in different way also. The pressure of different gases could be adjusted by evacuation. It means that first he took a discharge tube. Inside the discharge tube he is passing the gas. That gas which he is passing, the pressure of the gas can be controlled by evacuation tube. Okay, and he fixed the two sufficiently high voltage electrodes to check the voltage, and the current start to flow through the stream of particle moving in a tube, and from the negative electrode to the positive one. Current is flowing from negative to positive electrode. Okay, it is electrode is like a when you are observing a battery or a cell carefully, you can see inside these electrodes are there. These rays were called the cathode ray and cathode ray particles, and the flow of current from cathode to anode was further checked by making a hole in the anode and casting the tube behind anode and phosphorescent material called zinc sulfide coating. Now to which side the cathode ray is traveling, to check that we are fixing one fluorescent material called zinc sulfide coating, and the movement of electrons can be checked. Okay, so now discovery of electron in discharge tube experiment. So first though the electron can discover the electron, that J.J. Thomson has used a discharge tube experiment. Okay, so what is happening? We know that under normal condition of pressure, a gas is a poor conductor of electricity, basically. Okay, but if the pressure is reduced, if the gas's pressure is reduced, the gas also become conductor. So electricity start flowing through the gas. So William Crookes was the scientist. In 1879, he studied that the conduction of electricity through gases at low pressure. He performed the experiment with the discharge tube. As I said, the discharge tube length was 60 centimeter, and it is sealed with both the end with the fit two metal electrode, and the electrode are connected in the with the source of a high voltage tension battery, while the tube is connected to the vacuum pump. In order to reduce the pressure inside, the discharge tube is filled with the gas under study, and following studies conducted, they did basically 3 experiments. Okay, in first, what he did, under normal pressure, he observed that there is nothing. Even the voltage, he increased the voltage 10,000 volt also, but he was not getting anything under normal pressure. When he reduced the pressure a little bit, then the vacuum pump is working, and the pressure is reduced 10 raised to power minus 2 atmosphere. The gas found to emit light little bit. The color of light depend upon the nature of gas, like neon bulb have yellow color, CFL bulb have white color. Okay, and the emission of light that is ceases when the pressure is reduced more. When he reduced little more pressure, 10 raised to minus 4 atmosphere, he found that the discharge tube opposite to the cathode start. Mean cathode rays are starting opposite to the discharge tube, and he found a greenish light called fluorescence. This has been shown in the picture which is given in the PDF. So in this way he found that. So in this way his contribution was, he has found the ratio between charge and mass. When only electric field is applied, the electric deviate from their path and hit the cathode ray tube to point 1. Okay, this already I have explained. So what is the ratio? Ratio is E upon ME is equal to 1.758820 into 10 raised to power 11 coulomb kilogram. Keep the value in your mind. The basic properties of cathode ray, they have found after doing this experiment. First, cathode ray travel in a straight line. cathode ray travel in a straight ray like light. Cathode ray are made up of material particle. How it checked by them cathode ray is made up of material particle. Suppose in this discharge tube he placed a light paddle wheel inside in between path of this cathode ray. He is starting rotating, okay, and this show that the cathode ray consists of material particle. Only material is only continuously moving, okay. So cathode ray consists of negatively charged particle. How he checked? Because he found that those particles are moving toward the negatively charged, so negative is attracting positive. 1 unit negative charge he calculated minus 1.60 in 10 raised to minus 19 coulomb. These values are need to be learned, need to be keep in your mind while we are going to be solve the numerical. That time it will help, these values will help. Mass of electron is 9.1 10 raised to minus 28 gram, okay. After this, Thomson has done experiment. How? These are the two discharge tube. This is the discharge tube, and in 2 steps I am telling you. Thomson's experiment and discovery of electron. By passing the electric current to make a beam appear to move from negative to the positive end, and this positive end to moving toward positive end, this is called electron. And by adding an electric field, he found that the moving pieces were negative, and he called that moving pieces electron. Actually, what is happening? The moment he was passing toward the electric field, the movement of rays were toward positive side, and which is moving positive side, that was a positively charged particle, that is called negative, and those negatively charged particle he named electron, okay. After this discovery of proton, the discovery of proton is E. Goldstein. He noted stream of positively charged particle in cathode rays in 1886. Once the electron were discovered, then with the help of discharge tube, the E. Goldstein has found the one more positively charged particle, that is called cathode ray. Particle move in opposite direction of cathode ray. Anode ray. So particle was moving, those anode rays were moving opposite to the cathode ray. These cathode ray oppositely moving cathode ray particles were known as canal rays, because they passed through the hole. They were passing, these particles were allowed to pass, they were possible to pass to the next side by drilled through the negatively electrode, and canal ray must be positive. Goldstein postulated the existence of positive fundamental particles, which is called proton, and these proton are nowadays positively charged particles. And properties of anode ray or canal ray or positive rays. Anode ray travel in a straight line, and anode ray consists of material particle. Anode ray deflected by electric and magnetic field. Yes, these anode ray was deflected with the help of magnetic field and electric field. The value of these positive charge are E upon m ratio on the particle depend as same. 1 unit of negative charge is 1 positively charged 1.60 into 10 raised to minus 19 coulomb, and mass of an electron is 1.67 into 10 raised to minus. It is equal to, this value is same equal to the electron, but only the difference in charge. As in that case we have done negative 1.60, here we are doing positive 1.60. Mass of electron is 1.67. Mass of proton is mass of proton is 1.6067 into 10 raised to minus 24 gram, okay. So what is the structure of an atom? Like nucleus is the center of atom and home of proton and neutron. Inside the nucleus there is proton and neutron. Proton is positively charged and it has relatively mass 1 unit. It is determined by atomic number and found inside the nucleus, okay. Next is discovery of radioactive. So discovery of radioactive one, this is third point. After discovery of electron and proton by Thomson and Goldstein, Henry Becquerel in 1896 he came with a new substance while working with uranium salt. He was working with uranium salt, so he came with one more particles of the electron of the atom, that is called radioactive particle. He found that the salt emitted certain highly active radiations. These radiations are called radioactive radiations, in which positively charged radiation active is called alpha, negatively charged radiation is called beta, and the without deflection particle is called gamma, okay. So in this way, proton discovery we have done, electron discovery we have done, radioactive discovery we have done. Now this is discovery of neutron, third particle of the atom. In 1932, James Chadwick discovered another subatomic particle which had no charge. This was the most important thing. It doesn't have any charge and a mass nearly equal to that of the proton, and mass is almost equal to the proton. It was eventually named as neutron, and neutron are present in the nucleus of all the atom except hydrogen only. In general, neutron is represented with N, and the mass of atom is therefore given by the sum of mass of proton and neutron. To calculate the atomic mass, it is very important we should know the neutron. And what is the structure of atom? It is neutron has no charge. It is relatively mass is 1 unit found inside the nucleus and represented with small n. Similar way discovery of neutron, Chadwick felt that by bombarding a thin sheet of beryllium. So sometime question can come, how with the help of which element neutron is discovered? That is beryllium. By alpha particles. When electrically neutral particles having a mass slightly greater than of the proton, that is called neutron, and he named the neutral particle neutron. Thus this discovery was a very important discovery in the history of chemistry. Okay, so because electron make atomic number, electron, number of electron, if we know the number of electron, so we can find out atomic number. The proton is equal to the electron, proton is equal to electron, but neutron is very important, because if we don't know the neutron, we cannot find out the atomic mass. So to calculate atomic mass, we should know neutron. Okay, so this was a remarkable discovery. And the basic structure of atom, now we came to know what is the basic structure of atom. We studied about electron, proton and neutron. So electron, proton, neutron basically sub fundamental particle of atom, and number of proton is always equal to number of electron. This is the first fact. Number of proton make atomic number, and number of proton plus number of neutron make mass number. And number of neutron is how to calculate? It is mass number minus atomic number. Once again, number of proton is equal to number of electron always. If number of proton is 7, you tell what is the number of electron. Think, if number of proton is 7, if any atom whose number of proton is 7, so what would be the number of electron? Yes my dear, it is same 7. If number of proton is 10, number of electron will 10. If number of proton is 100, number of electron will 100. And number of new proton is called atomic number. So this is atomic number. The element which have 7 proton, it means that its atomic number is also 7. Okay, so number of proton plus neutron. Now number of proton plus neutron, these two, proton and neutron, it is making mass of any atom. Okay, this is called mass number. And number of neutron, how to calculate number of neutron? If we don't know, if we know number, suppose if any atom have 11 electron, so how many proton is there? Same 11, but we don't know neutron. So to calculate neutron, we can use this formula, mass number minus atomic number. So Thomson's after this basic structure, when we come to know electron, proton, neutron are the basic of subatomic particles, but we were not known that time where it is placed, how it is placed, how it is arranged inside the atom. So for that purpose, we have some basic theories: Thomson's Plum pudding model, Rutherford gold foil experiment, Bohr's model of an atom, and quantum set. So let's discuss Thomson model of an atom. J.J. Thomson, a British physicist, was born in Cheetham Hill, a suburb of Manchester, on 18 December 1856. He was awarded the Nobel Prize in Physics in 1906. For his work on the discovery of electron, he directed the Cavendish Laboratory in Cambridge for 35 years, and 7 of his research won Nobel Prizes. So 7 Nobel Prizes he won. He was very famous scientist. Thomson's model of an atom, according to Thomson, atom was spherical in shape. This was the model, and which has positively charged particle and negatively charged particle equally distribution, and hence it was electrically neutral because number of positive and number of electron was same. Its observation could be called a Plum pudding model or a watermelon model. Why it is called? Because the electron was discovered in 1896 by Thomson. He imagined the atom as a resin pudding. At that time there was no advanced compound microscope, so he has resembled his model with the resin pudding watermelon, and with electrons stuck in the cake. Like he said, as the small black seed inside the watermelon, you resemble that like an electron inside. This grain portion which is outside, this is you resemble like a proton. Okay, positively charged is this outermost layer green color, and negatively charged is this black seed. Okay, so he proposed a model of atom that is sometimes called the Plum pudding model, sometimes called watermelon model, sometimes rice pudding model. So atom was made up from positively charged sphere with negatively charged electron embedded in it. Positively charged are outside, negatively charged were embedded inside. This was his characteristics, and the negative and positive charge are equal, so the atom is wholly electrical stable. So that time, those people, those public, they adopted this theory, and they were thinking it was the model, but somewhere this model was failed. Reason? Because atom is not filled from inside, and electrons are not inside, electron is outside. So who has corrected that? Rutherford. Now we will talk about Rutherford. Rutherford was a New Zealand born British physicist who became known as the father of nuclear physics. He was born at Spring Grove on 13th August 1871. He was known as the father of nuclear physics. He is famous for his work on radioactivity and the discovery of nucleus of an atom. With the gold foil experiment, he got Nobel Prize. For gold foil experiment, he got Nobel Prize. Now, what is gold foil experiment? His model of atom is known as alpha gold foil experiment, in which famous experiment he did with the alpha particle scattering experiment. A stream of high energy alpha particle from a radioactive source was directed at a thin foil of a gold metal. The thin foil had a circular fluorescent zinc sulfide screen. Whenever alpha particle struck the screen, a tiny flash of light was produced at the point. So experiment, whatever experiment he did, what observation he did, what was conclusion, all these three we will do. The experiment, most of the alpha particle passed through the gold foil undeflected. The moment he passed the gold foil through the screen, though most of the gold foil, most of the particles passed from the gold foil experiment. So this theory, this thing shows that most of the space in the atom is empty, as J.J. Thomson was saying it was filled with the electron. So he proved him wrong. Most of the space inside the atom is empty because as the alpha particle passed through the foil experiment. Second, a small fraction of alpha particle was deflecting. A very small fraction of alpha particle were there which was deflecting after striking. So it means that a few positively charged alpha particle were deflected. So third, with very few particles, mean 1 out of 20,000. 1 out of 20,000. It was a rebound or bounce back that were deflecting nearly 180 degree, mean through which direction, which angle the light was striking, the same angle it would reflect back. So the positive charge has to be concentrated in a very small volume, and that repelled and deflected positively charged alpha particle. So basically from this experimental observation we conclude that the positively charged and the most of the mass of the atom was densely concentrated in the extremely small region. That concentrated small region is called nucleus. So he discovered nucleus. Second, the nucleus was surrounded by electron moving in a very high speed. The nucleus was surrounded with electron. This is second conclusion. The nucleus was surrounded with electron. This was also his advantages. And electron and nucleus are held together with the electrostatic force. This is also correct. So result of Rutherford experiment was most particle passed through the foil without any deflection. Yes, some of the alpha particle deflected at same angle, very few even bounced back. So this, because of this theory, we came to know the atom is empty inside, and there are a very few small region in between where positively charged particles are there, that is called nucleus, and from there it is bounced back, that is in between in the center neutron. So he resembled his gold foil experiment with the planetary model of atom, as J.J. Thomson resembled with the Plum pudding. He resembled with the planetary model, as around the sun all the 8 planets are revolving, the same way around the nucleus all the electrons are revolving. He resembled his planetary model. But what happened, some of the drawbacks and limitations were there. It couldn't explain the gravitational force in nature, as he said electron will continuously moving around the nucleus, and one time what will happen, it will emit all the energy, and with the energy emitting, electron will fall down in the nucleus. In that case the atom will destroy. Okay, but it couldn't explain planetary motion under the influence of gravity. It couldn't explain Maxwell electromagnetic radiations also, that we will discuss in the next. It couldn't explain quantum mechanism, as this also we will discuss in future. As the time was become advanced, some advanced microscope we got, and in that position this theory was failed to explain those all queries. The model created by Rutherford had still some serious discordance. According to the classical science, electron moving around the nucleus and planetary model of the atom is unstable, because in the planetary model of atom, electrons should radiate energy and finally fall into the nucleus. This was the drawback. Following Rutherford planetary model of the atom, it was realized that the attraction between the electron and the proton should make the atom unstable. Yes, the attraction between electron and proton will make the atom unstable. And then one more scientist came, Bohr. Bohr proposed a model in which the electron would stably occupy fixed orbital as long as these orbital had special discrete location. So dear students, nothing is new. J.J. Thomson, Rutherford, Bohr's model you have studied in 9th class also. Here we are studying a little bit more detail. So conclusion is what? Atom are the building block of matter. Thomson's atom model is the atom, is that atom in which positively charged sphere and the electron are embedded in it, and atom are neutral because positive and negative charge are equal. Rutherford did the famous gold foil experiment and said that there is a positively charged center in the atom which is called nucleus, and electron revolve around the nucleus in circular path. So with this conclusion, today we have done the discoveries of electron, proton, neutron and radioactive. and the basic structure of atom given by J.J. Thomson, Rutherford. Now, after drawback of Rutherford, there was some wave nature, particle nature, some of the theories. Then Bohr's model we will discuss with the help of atomic spectrum. Then after this, basic configuration, basic things. Okay, so hope so you enjoyed this video, you like this video, and you understood everything. If you still have some problem, some difficulties, so you can call me anytime. Okay, so this is all about for today. Still till my next video, stay home, stay safe, take care of yourself. Thanks for watching this video. Thank you. Have a nice day.